Cryogenic treatment. Now we can discuss about one of the good topic, that is cryogenic treatment. A cryogenic treatment is the process of treating workpieces to cryogenic temperatures, that is below 190 degrees C, in order to remove residual stresses and improve wear resistance in steels and other metal alloys such as aluminum. In addition to seeking enhanced stress relief and stabilization or wear resistance, cryogenic treatment is also sought for its ability to improve corrosion resistance by precipitating microfine carbides, which can be measured before and after in a part using a treatment. Dear friends, I am also preparing the notes to explain without missing the option. That is the information I want to share with you. Cryogenic hardenance. Cryogenic hardening is a cryogenic treatment process where the material is slowly cooled to very low temperatures by using liquid nitrogen. The temperature can go as low as minus 196 degrees. It can have a profound effect on the mechanical properties of certain materials such as steels or tungsten carbide. In tungsten carbide, the crystal structure of cobalt is transformed from softer FCC to harder HCP phase, whereas the hard tungsten carbide particle is unaffected by the treatment. Applications of cryogenic processing: aerospace and defense, communication, optical housings, weapons platforms, guidance systems, landing systems, automotive, brake rotors, transmissions, clutches. Automotive lo what are the informations are there in automotive regarding cryogenic treatment? Brake rotors, transmissions, clutches, brake pads, rods, crankshafts, camshafts, axles, bearings, ring and pinion heads, valve trains, differentials, springs, nuts, bolts, washers. Cutting tools. In cutting tools, cryogenic treatment will be done how much? Cutters, knives, blades, drill bits and mills, turning or milling inserts. Cryogenic treatments of cutting tools can be classified as deep cryogenic treatments around minus 196 degrees C, or shallow cryogenic treatments around minus 80 degrees C. Forming tools: roll form dies, progressive dies, stamping dies. Mechanical industry. Regarding mechanical industry, pumps, motors, nuts, bolts, washers. Medical. Regarding medical, tooling and scalpels. Scalpels, that means covering leads. Motor sports and fleet vehicles. Motor sports and fleet vehicles. See automotive for brake rotors and other automotive components. Musical, vacuum tubes, audio cables, brass instruments, guitar strings and fret wire. These will come under cryogenic treatment. And piano wire, amplifiers, magnetic pickups, cables, connectors. Regarding sports, firearms, knives, fishing equipment, auto racing, tennis rackets, golf clubs, mountain climbing gear, archery, skiing, aircraft parts, high pressure lines, bicycles, motorcycles. In cryogenic treatment, cryogenic machining is what? Cryogenic machining is a machining process where the traditional flood lubro cooling liquid. An emulsion of oil into water is replaced by a jet of either liquid nitrogen or pre-compressed carbon dioxide. Cryogenic machining is useful in rough machining operations in order to increase the tool life. It can also be useful to preserve the integrity and quality of the machined surfaces in finish machining operations. Cryogenic machining tests have been performed by researchers since several decades, but the actual commercial applications are still limited to very few companies. Both cryogenic machining by turning and milling are possible. What are the advantages of cryogenic treatments? Comparison of cryo rolling and rolling at room temperatures. In cryo rolling, the strain hardening is retained up to the extent to which rolling is carried out. This implies that there will be no dislocation, annihilation and dynamic recovery, whereas in rolling at room temperature, dynamic recovery is inevitable and softening takes place. The flow stress of the material differs. For the simple which is subjected to cryo rolling, a cryo rolled sample has a higher flow stress compared to a sample subjected to rolling at room temperature. Cross slip and climb of dislocations are effectively suppressed during cryo rolling, leading to high dislocation density, which is not the case for room temperature rolling. In cryogenic treatment, the corrosion resistance of the cryo rolled sample comparatively decreases due to the high residual stress involved. The number of electron scattering centers increases for the cryo rolled sample, and hence the electrical conductivity decreases significantly. The cryo rolled sample shows a high dissolution rate. Ultra-fine grained structures can be produced from cryo-rolled samples after subsequent annealing, not annealing, annealing, A-N-N-E-A-L-I-N-G, annealing. That is the information I shared with you regarding cryogenic treatment. It is also a very good subject. So I shared you regarding, I want to give a basic idea regarding what is cryogenic treatment. This is the information I shared with you. Wishing you all the best. May God bless you.